My name is Marina Volchek. I'm from HPE company, Hewlett Packard Enterprise company, which is an American multicultural IT company with more than 200,000 employees across over the globe, including new offices here in Cluj. Our company was founded about 6 months ago, and the result of a big split of the HPE company to two different companies. One is focusing on Okay, that's better. Thank you. So we founded as a big split for HP company. One is focusing on printers and laptops and other kind of stuff, and our company is focusing mainly on software and the services. So I'm very excited to be here today. It's my first visit in Romania. I was born in Russia and moved with my family to Israel. And today, this evening, we are celebrating the Independence Day of Israel. And actually, it's good for me to celebrate this holiday here because it's good for me. The people there in Israel go out and have barbecue from the morning till evening. So, okay, so what I wanted to present you today is one of the ideas we implement to address challenges that we meet every day. Okay, so we on the web stage, we are talking about web application. Whatever web application you develop, whatever methodology your company follows, we see more and more companies going in the agile methodology way, meaning frequent deliveries to the customer, getting feedback from the customer to ensure that we are going to the right way. But it doesn't even matter if you're in a small company or in a big enterprise company. What we developers need to do is to develop faster, deliver faster with a high quality. That's what we need the automated testing. This is our confidence to minimize the possible regressions from the constant code changes. And there are many different kinds of automated tests. I just put this slide from Google presentation just to show you that the foundation of this pyramid, the foundation of entire automation strategy is unit testing. Unit tests are efficient type of testing and probably most frequently used. So it's checking the small pieces of code. They run quick to run, and we have a lot of them. Okay? But the unit testing writing consumes a lot of effort. Developers investing too much time in writing and maintenance these tests that frequently change. So what is the optimum level of coverage? As we understand, the low coverage is not good for us due to high risk for the regressions, and the full coverage to cover each and every component in our code probably is not a realistic case. So we need something in the middle. We need to find the balance between the code writing and testing writing to cover this code. Okay, so probably it should be some magic number between 0 to 100% of coverage. So this is what usually managers do. They define some number, some threshold for the minimum coverage, and then developers need to work very, very hard to meet this threshold for each and every file, or most of the files in the system. But the code is created not equal. Some components are more important to cover, to test, than another. So this was our challenge. Last year we started a very big project with about 200 developers from different countries. And what we wanted to do is to find a way to define these important components in our code. Okay, so we the brainstorming and defined two main criteria. Think about the big project. We have hundreds, maybe thousands of files. Okay, so how to define what is important? So we took two main criteria. The first one is usage frequency, meaning how many different components in the code are using my component. And the second one is change frequency, meaning how often developers make changes in my component. These two criteria help me to balance and say that more frequent used code pieces like platform services, infrastructure files, or frequently changed files will have high coverage. And the code segments like a legacy code, third-party components that have been changed not so often or less used will have less coverage. There are many tools in the market for the code coverage measuring. Our method is unique and was patented due to two things. The first one, we consider also change frequency, like I mentioned it before, and not just usage frequency that other tools only focus on. And also we have dynamic threshold, not static like coder tool. So actually this method includes 4 steps. The first step, as we already talked about, we calculate the usage frequency. Then we need to calculate the change frequency. We need to define the threshold for the minimum coverage and enforce this threshold in the build. So we can calculate the usage frequency in different ways. Actually, there are 2 techniques. The first one is static code analysis, and the second one is runtime code analysis. Of course, the static code analysis depends on technology that our code is written. For example, as you can see, the Java we can just count the number of imports down to the package in the offline mode. And the runtime code analysis requires the instrumentation to the code to calculate, to sum a number of each file's usage, okay, and collect all this data during the runtime. Okay, so here you can see the example from our project, the real JavaScript files and their usages. The second step is actually a calculation of changes, okay? So we can just count the amount of the commits per file, okay? And actually this data you can get, you can expose from any source control that have the APIs, okay, like Git. And you can see, again, the example of our files, the number of commits per week. Okay, so as you understand, we have the usages calculation, we have the commits calculation, and now we can get the weights, W1 and W2 in this line. If you want 50-50, if you want maybe consider more usage or commits. And then we need actually to take the maximum number between this calculation and current coverage, of course, and define this threshold per file. Why we need the current coverage? Let's say we do some refactoring and reduce dramatically the usage of specific component. Okay, so the right part of this formula reduced, but we have some current coverage, we want to reduce it, right? But if the usage is growing or the number of commits is growing and the right part became bigger than the current coverage, then we want to update this threshold per file and actually to enforce this coverage. And the last part, actually we have to integrate this threshold enforcement in the build, right? During the developers commit, during the builds, and of course the dynamic part that we talked about in the patent slide. Actually, we need to repeat steps 1 to 3, meaning the usage calculation, frequency calculation, and defining the thresholds every time changes in order to ensure that the thresholds are always relevant and represent correctly the importance of each and every file. Okay, so it was the method and the patent. And now we took this idea and tried to implement it in our project. We have an Angular on the front end. And as you remember, the first step was to calculate the usage. In Angular, it means to calculate Angular services and their usages. We define to go not with the static analysis, but with the runtime static code analysis. And we reuse the Batarang code. Batarang is an AngularJS application available as a common extension that actually get us visualization of many insights of Angular, like performance of the application and dependencies. Okay, so Batarang already does this work for us, the dependencies calculation. So what we needed to do just to take these functions, okay, and just modify them to count these dependencies and create the map of Angular services with their usages. Batarang functions override provider service, meaning it is doing the Angular bootstrap in the runtime. Okay, and also the start point for us, you can see the code of Batarang without changes. And then so in this way we created this map during Angular bootstrap. And also we created one small Jasmine unit test, which triggers all this instrumentation. Meaning, if you remember, we need to recalculate this map every time period. Meaning we have some job, okay, the background job that runs every time period, run this unit test, and this unit test actually do the work. That's the work, okay? It is calculating the map. Okay, the second step. Actually, in the beginning, we just took the number of commits from the Git. And these days, we try to combine some HP internal tool that not just count the commits changes, they bring some more smart statistics about the code changes. So in this way, we want to enhance this part, the commits part in the format, okay? In order to define the minimum coverage threshold per file. Okay. And finally, we took this map. We can see the list of Angular services. And we can see what is the top used services in our project. You can see, it's not, you can see it, but actually we see the JSON with the JavaScript names and the number, which is actually our, don't know if you see it, but we have 42, 92, 42, and so on numbers, meaning every JavaScript file has different code coverage threshold, okay, based on usage and changes. And of course, we filtered out some third-party components, JavaScript files, and legacy code, because even if they are mostly used, that they have very low change frequency. Okay, and the last step, it's actually enforcement. We did it in two ways. The first one, during the hook push on the dev mode, means every developer before he commits his code, he needs to run this task. This task is doing the following. We are using the curl tool to get the current status, okay, current coverage, just get this report. And then we are looking at the file that I just showed you in the previous slide. And in case of violation, we give this error to the quite coverage. And the last slide, actually, 2 minutes ago, and the last step is actually our Jenkins screenshot. Actually, developers can not run the push and do commit a change. So we want to also to have this enforcement on the view level. So in this case, we create some post-build action that actually checking this code and actually and the threshold and actually makes our build unstable. It doesn't make it red, it makes it yellow, but it is good enough because we need to keep our build the green all the time.
Short to about the length of a tweet, but so I'll just start the ball rolling. You can tweet us if you want at EDT or stick your hands up. But my first question is there a maximum size of project that you think can be covered with this, or can this scale up to massive projects?
We are talking about massive projects.
Yeah, I mean, how big is the...
because of project. Okay, so let's see. We have about 200 developers. 200 developers. Actually, it's our big first project in the Agile methodology. Okay, in the past, actually, HPE has a lot of software projects. It was, the four-quarter flow way. And when we are talking about Agile, meaning every month we have a push to production, meaning new content to customer every month. And every 3 months, because our model is also as a software as a service. And on-prem installation, meaning software as a service, we have every month pushing. And at the on-prem, we have every 3 months. Okay, so we don't need the different branches, we just take the code every 3 months and deliver it to customer.
Fantastic. Okay, so time for a question. So if you have a question, please raise your hand. Very quick at the back there. I'll just wait for, I think the microphone is coming towards you. A gentleman with a very fine beard, almost as good or slightly better beard than mine. Your question, sir?
It's open source.
Is it open source?
Actually, our product is not open source, but this idea, we have two parts. We have the idea as a patent, as a method. You can implement it in very different ways. I just show you how we did it. Okay, so we don't talk about some specific code. Okay, we talk about the entire system. We need this, we need code, we need job, okay. But our products are some of them are open source. The specific project come to.
Okay, very interesting. Obviously, this is as much about methodology as it's about doing the work as it is the specific tools as well. So, do we have another question for our speaker, or has she told you everything that you need to know? You're full of knowledge. Is that a question, or you just scratching yourself? That's a question there. Yes. Let's just wait 1 second. Okay.
This looks similar to an open source project called CodeFinder. Is there a reason why you didn't use something already available and you just chose to build it yourself?
The fact that we have a patent on this idea, meaning there is no exactly the same method in the market. Okay, so as I said, the differentiations come from changes and usages together, okay, and the dynamic threshold. Because most of these things, or most of the tools, use a static threshold, okay, so it doesn't change, but the code has no change, so we need some dynamic threshold. Okay, so this is the answer.
Okay, great question, very good answer. Any more? You're standing between people at lunch, so let's have any more questions for Marina? No? Okay, well, in which case, a very big round